Welcome to Forces Unit 1, Lesson 3. This is doing calculations using vector quantities. For this lesson, you're going to need a pen or a pencil, something to write with, and a piece of paper or book, that's something to write on. You can use a calculator if you want to as well. Pause the video, go and get those things if you don't already have them. When you press play, we'll get started. Okay then, let's go. As always, we start off with a little mini test, a little recall test on what you've done previously. These are the questions then. Pause the video, write your answers on a piece of paper, and then press play again, and I will go through and see how you've done. Let's see how you've got on. What is a quantity? That's something we can measure. Quantities that just have size are called scalar quantities. Distance and speed are scalar quantities because the direction does not need to be included in any calculations. Quantities that have magnitude and direction, so having direction as well, called vector quantities. If it's distance and direction, that vector quantity is displacement. Speed and direction, that vector quantity is velocity. Well done if you've got all of those right. Let's just recap a couple of problems from last lesson. There was this problem up here with the people stood 2 meters from each other, and because the direction wasn't specified, you could have had a number of different answers, so that wasn't very good. So the direction sometimes does matter. And here we have the 2 people running, and we were looking at the time it takes for them to meet each other. And of course, depending on the direction, you could have several different answers. So sometimes direction does matter. So how do we put directions into calculations? So when we've got directions involved, we're calling them vector quantities. Well, the answer to that is we can say which direction is forwards and then use a plus and a minus. Let's have a look here then. You cannot put forwards and backwards into a formula. So this is forwards, someone walking forwards. We can't put the forwards into the formula. Here's someone walking backwards. We can't put backwards in. So these are no good. We can't do that. So the way we do it is we say to the right is forwards. So this way is forwards. And this one has a velocity now of 5 meters per second plus 5 meters per second. They're going forwards. This person here has a velocity of minus 5 meters per second because they are going backwards. So we don't have forwards and backwards included now. We just put a plus for forwards and a minus for backwards. Really simple. So a couple of key ideas for you to write down then. Jot them down on your piece of paper, pause the video, press play when you're ready to continue. Okay, let's go back to a question we did last lesson. This is Amy and Mary again, 20 meters away. They both run at 1 meter per second. How long is it before they meet? For last lesson, we said it's not a very good question because there are a number of different answers. For example, this one, or this one. So on the first one, they never meet. On the next one, takes 10 seconds. On the third one, of course, they never meet. And the big thing here was direction does matter here. We need a way of putting directions into calculations. Well, let's have a look at how they could have written that question. So it'll be much easier. So with vector quantities, it'll be much easier to work out what they're getting at. So let's have a look now at how they could have written this question. So there's our original question. Amy and Mary are 20 meters away, etc., etc. Well, starting off, Mary is in front of Amy. So we're going to put this into a little diagram. Always find a diagram is a really good way of making you understand how a problem works. So there we go. There's Amy and Mary. Now, because we're now using vector quantities, we're now using velocities. We're going to actually define which way is forward. So I'm going to have forwards going that way, and then we can add Amy runs with a velocity now of 1 meter per second. So there we go, because she's going forwards, because she's got a velocity of +1, she's going forwards. We put the arrow going that way. Then we put Mary runs with a velocity of -1 meter per second. Mary's going backwards. You can see you've got the -1, it's going the opposite direction. And how long is it before they meet? So that bit is the same. Well, that is quite simple. The way you would do this, to calculate the impact velocity, you take away Mary's velocity, which which is -1, from Amy's velocity, which is 1. So 1, take away -1, minus is a plus. The impact velocity is 2 meters per second. And at 2 meters per second, a 20-meter distance will be covered in 10 seconds. So that is how we could have rewritten that question using the idea of velocity. And there's no ambiguity there. There's no possible answer apart from the correct one. Let's have a look at another question, similar sort of idea. So one train travels at 20 meters per second, another train travels at 21 meters per second. They collide. What is the impact speed? So have a go at doing this problem on your piece of paper in front of you. Pause the video and I'll go through the correct answer in a moment. Okay, let's have a look at this problem then, see what you might have come up with, and then work out why the direction is important in this problem. Oh, you could have had this. You might have come up with one going at 20 meters per second, one going at 21 meters per second, and the impact speed is 41 meters per second. If you got that, you might have got it right, but there is another answer. You might have had it like this. One's going at 21 meters per second, one is going at 20 meters per second, and this time you've got an impact speed of 1 meter per second. Now, here's the problem. 41 meters per second is really, really, really fast. We're talking train derailment, people dying, real carnage, sort of big major disaster. Impact speed of 1 meter per second is slower than walking speed. About walking speed, just a little bit slower. Someone's going to spill their cup of tea, you're going to get a little bit of a jolt. People are going to go, oh, I don't think that was very good, but no real injuries. So it makes a big difference. And the answer is, we don't know which of these is right because the question wasn't written very well. The direction is important, and that hasn't been included at all in the problem. So how could they have done the problem differently? Right, well, let's split the problem into two then. If the top one was what they meant, then we'll do the calculations and things for that. Or if the bottom one was what they meant, we'll do the calculations for that. So we're going to actually convert all of this into vector quantities. So the first thing we need to do is decide which way is forwards, and I'm going to go forwards to the right. So let's rewrite the first bit of the question. How should they have written it? They'd written it like this. One train travels with a velocity of 20 meters per second. Another train travels with a velocity of minus 21 meters per second. They collide. What is the impact velocity? Well, that would have been the top one, 20, 21, well, minus 21 there, you can see, because it's going backwards. So that is 20. That is now minus 21. You can see the impact velocity is 20, take away minus 21, which equals 41. So the impact velocity is 41 meters per second. The unit is extremely important here, so we've added that in. On the other hand, if it was the bottom one they were getting at, they would have written it like this. One train travels with a velocity of 20 meters per second. Another train travels with a velocity of 21 meters per second. They collide. What is the impact velocity? So let's have a little look at that. That is still 21. That is still 20. The calculation, impact velocity equals 21, take away 20. These two numbers here equals 1. So the impact velocity now is 1 meter per second. You can see by calling them velocities and giving them pluses and minuses, it makes it quite clear which direction they are traveling in. Okay, let's go back a couple of lessons, a little mini test for you now. This is back to our tug of war. Let's have a look at this then. A little problem for you, balanced and unbalanced forces. I'm going to give you a few moments, see if you can work out what's going on, and I'll go through the answers in a minute. Pause the video. Okay, let's see how we've got on. What should you have done? Well, you should have added all of these numbers here together. 400 plus 500 plus 600 means a total resultant force to the left of 1500 newtons. And here, you should have added these numbers together. 8 plus 4 plus 500, 1700 to the right. Resultant force of these here, resultant force is 1700 newtons. And obviously, The resultant force of these two is 200 newtons to the right. So the resultant force, 200 newtons to the right, means the rope moves to the right and the team on the right wins. Well done if you've got that right. Was there an easier way of doing it using vector quantities? Well, yes, there was. You start off by defining which way is forwards, and we're going to have forwards to the right. And all you've got to do is have these numbers. Remember, if it's going forwards, it's a positive number. If it's backwards, it's a negative number. So this one becomes minus 400. This one becomes minus 500. This one becomes minus 600. 800, 400, 500 as you would expect. And all you need to do to find the resultant force is add them all up. There we go. Minus 400 plus minus 500 plus minus 600 plus the 800, 400 and 500 gives you the resultant force of 200 newtons. Now, because 200 newtons is a positive number, it's going forwards, which is to the right. So the resultant force goes forwards, 200 to the right. How easy is that? Right, little problem now for you to do by yourself. This is Robert and Jane walking and running. My advice to you when you do this problem is try and draw out on a piece of paper a little diagram of what's going on. Then it will become, I hope, very easy for you. So do a little diagram, that will help you. Pause the video. Okay, let's see what you should have done. Well, start off with a diagram. It says, well, start off by defining which way is going to be forwards. I'm going to make forwards to the right, and I'm going to put in Jane and Robert. It says Jane is behind Robert. That's okay on my diagram. It says Robert's walking at 1 meter per second, so let's add that in. There's Robert's velocity. And Jane is going at 4 meters per second. We're going to add that in. The collision velocity when Jane runs into Robert, well, that's quite easy. It's Jane take away Robert, 4 take away 1 is 3 meters per second. Again, unit is very important. If you've got that right, well done. Right, to finish off for today, we're going to do a little mini test. What I want you to do is go back and read the key learning ideas from this lesson and the lesson before, the stuff that you've written down. So it will be this stuff here about calculations, where directions matter, using vector quantities and how to do vector quantities, and the stuff from the lesson before, which is this stuff here, quantities, something you can measure, etc., etc. So you'd have all of those written down from today's lesson and the lesson before. So pause the video, spend a minute revising them, then you can press play again and have a go at the closing activity for today. Pause the video now. Okay, let's have a go at the activity then. All you've got to do is match them up. It's like a game of pairs, really. You should end up with 6 sentences at the end of the day. You end up with 6 sentences. Pause the video. Okay, let's see how you've got on then. Well, this is what you should have come up with. If you've got any wrong, then do your corrections now. If you've got them all right, then well done. There we go. That's it for today's lesson. That's all, folks.